Hello all, welcome to my YouTube channel. In this presentation for the next 10 minutes we are going to talk about Levenshtein distance, which is also known as edit distance. So this is an algorithm that is used to convert one string into another string with the minimum number of operations performed on them. So the operations that we can be performed are insert, delete and replace. So let us take one example to understand this in a better way. Here I have taken string 1 to be Sunday and string 2 to be Saturday. Now our task is to convert string 1 into string 2. That means I wanted to transform this UN in Sunday to ATUR in Saturday with the minimum number of operations that it can take. So the operations which can be performed are three. Those are insert, delete and replace. So for this problem I will show you two different solutions to get the optimal solution. So first one is you can replace U with A and you can also replace N with T and you will insert U and also insertion of R. This will be first method which takes 4 operations to be performed. Now for the second method you can simply replace N with R and also you can insert T and also you will insert A. This will be our second method which will take only 3 operations to be performed, which is minimum as compared to 4, and this will be our optimal solution for this problem. This problem can be solved in many different approaches, but we will prefer dynamic programming approach because it uses a table to store solutions of subproblems to avoid recalculating the same subproblems multiple times. So if same subproblems are repeated during the execution, we will simply retrieve the solutions from the table itself. Also, in dynamic programming, we can solve this problem in either using top-down approach or bottom-up approach. But bottom-up approach or tabulation is more preferred due to its simplicity. Now let us look at the algorithm for this problem. First of all, we will create a matrix D of size m plus 1 into n plus 1, and then we will initialize all of its rows from 0 to m using a iterative variable I, and then we will initialize its columns from 0 to j with an iterative variable j. Now there is a for loop which runs from 1 to n, that means size of the string 2, and inside it there is another for loop which runs from 1 to m, which is the size of string 1, and if string 1 of I matches with string 2 of j, then the cost will be assigned to 0, else it would be assigned 1. And then we will take the minimum value from all the deletion, insertion and replace operations, and then we will assign it to the d of I and j. And at last we will return d of m, n. Let us consider another example that converts teacher to lecturer. So in this example we are taking string 1 as teacher and string 2 as lecturer. So we have to transform string 1 to string 2 with minimum number of operations. So as we all know, the operations which we can be performed to transform string 1 to string 2 is insert, delete and replace. So now with these operations we have to transform string 1 to string 2. Before that, let me draw a 2D matrix which is used to store all the subproblems because we are following the dynamic programming approach. So this is our 2D matrix which is used to store the values of subproblems, and this is of size m plus 1 into n plus 1, where m is the length of string 1 and n is the length of string 2. So let us see, this is the final answer which we will get. And these all are subproblems that are to be stored. So here it will take only 0 operations, that means no operations, to convert empty string into empty string. So we will fill this cell with 0. And it will take one operation, that means one insertion, to convert empty string into L, that means one insertion. So we will fill this cell with 1. It may take 2 operations to convert this empty string into LE, that means 2 insertions, 2. And so on. If you continue, you will require 8 insertions to convert empty string into lecturer. And now it may take 1 deletion to convert T into empty string. So here we will fill this cell with 1. And it may take 2 operations, that means 2 deletions, to convert TE into empty string. So 2 operations. And like that, if you continue, you will fill the table with these values. And now let me draw a key table which will be used to fill our values. So this is our key table. Suppose if you wanted to fill this cell in this table, we wanted to see whether which is minimum in replace, insert and delete. That means you have to take the minimum of these 3 values and we should add +1 to it. Minimum of 1, 0, 1 is 0. So we will add +1 to it and then it will become 1. And if we continue the same process, the minimum of 1, 1, 2 is 1, 1 plus 1 is 2. The minimum of 3, 2, 2 is 2 plus 1 is 3. And the minimum of 3, 3, 4 is 3 plus 1, 4. And so on. If you continue, the values will become 5, 6, 7 in this row. The minimum of 1, 1, 2 is 1. 1 plus 1 is 2. So we will fill this cell with 2. And now observe it carefully. We are having minimum of 2, 1, 2 as 1. But you should not add +1 in this case because here E and E are identical. We will add +1 to the cell which is not identical. But here E and E are identical. So we should not add +1 to it. We will simply write the minimum of these 3 cells, that is 1. So write it as 1. And A and E are not identical, so we will continue the process which we are following before. The minimum of 1, 2, 3 is 1. 1 plus 1 is 2. And if you fill the table accordingly, you will land in the same situation here because C and C here are identical. As I said before, you have to take only the minimum value if you see 2 characters are identical. So we will simply write this as 2. And then the minimum of these 3 values is 2. 2 plus 1 will become 3. And the minimum of these 3 will be 3. 3 plus 1, 4. And continue like this, you will get 5. And you might think here T and T are identical, but no, these are case sensitive. So we should consider this small t and capital T as 2 different alphabet, and we have to perform the same operation like finding the minimum of these 3 values plus adding 1 to it. So it will become 4. So after filling the whole table, the table will look like this, and these 5 will be our final answer. That means we require 5 operations. We require 5 operations to convert teacher into lecturer. They will be replacing H with R and replacing C with U and replacing A with T, inserting C and replacing T with L. Always remember, you will compare the strings from the right side. And these are the 5 operations that are to be performed to convert teacher into lecturer. Now let's see the best and worst cases of this algorithm. So the best case of this algorithm occurs when the two strings are identical. That means in string 1 we have taken apple and in string 2 we have taken apple too. Now it requires 0 operations to transform apple into apple because they both are identical. So these can be considered as the best case of this algorithm. Worst case of this algorithm occurs when none of the characters in both the strings match. In string 1 we have taken giraffe which is of all capitals, and in string 2 we have taken giraffe with all small letters. Now it may require the length of string 2 operations to transform string 1 to string 2 because none of the characters match, because they are case sensitive, and this capital G is not similar to the small g, so it may require length of string 2 operations to be performed to convert string 1 to string 2. So these can be considered as the worst case of this algorithm. So the time complexity of this algorithm will be order of m into n, where m is the length of first string and n is the length of second string. Because we are using two for loops, this complexity will be occur. And the space complexity is also order of m into n because we are using a 2D matrix which is of length of these two strings to store the subproblems. So now let us see the implementation of this algorithm. Here I am using C++ language to implement these. As you all know, these are preprocessor directives and these are header files. This is for input-output stream and file handling, vectors and string manipulation. Here we are using namespace std because it simply allows us to write cout and cin wherever they are without writing std : every time we use them. And as you all know, the execution of any code starts from its main function. Let us look at its main function. Here I have chosen a variable called choice which is of character type, and I simply wanted to take input from user, whether he wanted to give input or he wanted me to take input from the secondary storage, and I will store that value in choice. If the user enters M, then it simply represents that he wanted to give the input manually, and then I will ask user to input his first word, and then I will simply ask user to input his first word and second word. And then here I have two variables, integer variables m and n, which are used to store the lengths of word 1 and word 2. After that, here I have taken a dynamic vector named dp which is of size m plus 1 into n plus 1. This is used to store the results of subproblems because we are using dynamic programming approach. And here I have taken another dynamic array of character type named operations to store the operations performed on that word 1. And now I also have another variable named distance which is of integer type, and it is simply calling the min distance function and passing the arguments word 1, word 2, dp and operations. Remember, dp and operations are dynamic arrays. That function call will simply call this function. Here int represents that the return type of this function will be an integer. Inside this function I also have m and n of integer type which are used to store the lengths of word 1 and word 2. So this loop is used to calculate the minimum distance between word 1 and word 2. And here S simply represents that the operation is replacement or substitution, and I represents that the operation is insertion, and D simply represents deletion.
After executing this function, it will finally return dp of m and n. Don't forget that dp is a two-dimensional array. Value returned value will be stored in this distance. So after that, we will simply displace the distance between those two words and the operations performed on those two words. This is first method when the user wanted to give input manually. Let us see how we can take input from secondary storage. If user enters S as his choice, then it will simply represents that we wanted to take input from secondary storage.
So here is the input.txt file and it has two strings. The first line will be considered as word 1 and the second line will be considered as word 2. If we have any difficulties in opening the file, then it will display a proper message to unable to open the file. And after that it will take inputs from that file and performs the same operation as we have seen before. If the user enters neither M nor S, then it will simply display a proper message that invalid choice, please choose either M or N. Let us see the outputs of this code. Besides having a lot of applications for this algorithm, I have listed few of the important applications. Those are autocorrection, data cleaning, data clustering, and spell checking. So despite having many applications for this algorithm, there are some limitations too. The computational complexity and the memory usage are the most concerned one. If you enter string 1 and string 2 to be large number of character sequences, then it will take more space to store these two strings, as well as the computational time complexity will be more expensive. So these are said to be the limitations of this algorithm. I hope you guys have understood well, and if you have any other questions, don't hesitate to mail me or do let me know in the comment section below. And if you guys like this video, don't forget to like, share and subscribe to my YouTube channel. For the detailed code, I will provide you my GitHub link in the description box. Thank you so much for watching.